Now, again, today, guys, I think we're gonna have another little quiz on Friday, I believe, over just these three, section 3.1, 3.2, and 3.3. Okay, thank you. You didn't get it? Okay, that's okay. That's all right. Shh. You have it with you or not?
Yeah.
All right, sorry about that. All right. Now, again, please, we're going to take, all right, today now, you guys have one little disadvantage because my other class has had 2 years of fractions, and you guys have really only had what? One. All right, so you guys got to really step up now, and as soon as you don't know something, you got to let me know. All right, you got to let me know right away. All right, this whole week is very important with fractions. You got to be a master of fractions. All right, so here we go. Now, right now, this is considered a mixed fraction, and what they want you to do is they want you to write it as an improper fraction. All right? So do you remember how to write it as all right, so what would you think the answer is here?
It should be 15 over 4.
15 over 4. All right? Now explain to me how we got that.
4 times 3 is 12, plus 3 is 15. The denominator stays the same.
That is correct. Denominator stays the same, so I'm pretty happy with you on that. Does anybody have any issues? It may have been a while. All right? Everybody comfortable with that?
I don't know about
Yeah, just let's go. Let's go. Okay? The more I do in class, the less homework you have. I already left it up there for 5 minutes while you were playing around. You didn't get it. So now just watch and do the problems with me and figure it out later. All right, question number 2. Write that as a fraction. Tell me. Yes, just simply negative 9 over 1. You okay? All right, I don't want you stressing out, man. Let's go. All right, don't worry about it. Just stick with them, okay? Don't worry about the page. Don't worry about heading. Just join me right now. Come on, I'm worried about you. Hurry up. Yes, ma'am. Say it again. Well, what's 9 divided by 1? What's 9 divided by 1? Yeah, that's why. They're just asking you to write as a fraction. That's all. You should know 9 is the same as 9 over 1. You with me on this? Okay, that's all. Nothing to it. Really, super simple. All right? All right, let's check out number 3. All right, so now you got to be careful because some of my kids last time thought it was negative 1 times 4. You're not doing that. Michaela, what's the answer? Yes, perfect. Negative 7 over 4. Now's the time you're speaking up and say, hey, I'm not sure. Anybody have a problem with that? What?
Why were you doing that?
Because this is negative, and then it's 1 3/4. The negative, all right, is not being multiplied by the 4. It's just 4 times 1 plus 3. Okay? It's a negative number. Yes, ma'am. Yes, that's exactly correct. All right, that's exactly right. What?
You just have the negative half.
Oh my goodness. Yes, we've said that now 3 times.
So anything with a 9 is 9 over 1.
How do I make 4 a fraction? Yeah, you can just make it what? 4 over 1. Any whole number can be written as a fraction. Just 4 over 1. 5 can be 5 over 1. 6 can be 6 over 1.
If the entire number is negative, why would the second just be negative?
Well, it just doesn't matter where you put it. Watch what I mean by that. It could be that. It could also be this. The negative can be on the bottom, out in front, or on the top. We just traditionally write it on the top. You know that? Okay, concentrate now. What? Go.
If you were to turn that fraction into an improper fraction, would the negatives go back to the number?
What? I'm not sure what you're
If you turn that fraction into
What fraction?
the 7 over 4, negative 7 over 4, if you turn it back into an improper fraction, would that become negative 1 and 4?
Yes, because they're equal. These two things are equal. You agree? They're equal. They're both negative, right? Everybody okay so far now? All right, let's see what we can do on question number 4. All right, so now you just have to remember how to convert a decimal to a fraction.
So, if that's a decimal,
Just tell me what the answer is.
7.
7 over 0.07? No, read this decimal for me. What does that number say? 7 what? So what's the fraction? You don't even realize you just said it. What's the answer? So you're saying something. I need you to understand what you're saying. Say it again. 7 what? So what fraction is that? No, you're not. Say it again. So that's the fraction. What's the fraction? That's literally what that means. 7/100. When you said that, 7/100, that's the fraction. 7 over what? 100. That's literally what that means. That's why I say I'm not sure why kids have so much trouble with decimals. If you can read a decimal, then you can write it as a fraction. That makes sense now, right? All right, everybody okay with that? All right, let's check out the next one now. Uh-oh. Uh-oh. What?
It's negative 3 and 85.
Yes, sir. Thank you. Those of you guys remembered. We talked about this last week. Negative 3 and 85 over what?
99.
Beautiful. Negative 3 and 85 over 99. Yes, ma'am. Just because it's a pattern in math. Anytime you have something repeated, remember last week I told you what about 0.1 repeated? What's that? Remember? 1/9, right? And 2 repeated was what? That's right. You with me? So 85 repeated is going to be? That's how it's just a pattern. Later on I can show you the math, but we don't really know how to do the math right now, so it's just something I tell kids it's good to know. What?
How come it's repeated the 8 and 5,
The line is over what? No. If it's over 2 numbers, it's over what? There you go. What if it was 3 numbers? That's all there is. That's how simple it is. It's just a pattern in math. It's kind of weird how it works out, but that's it. Okay? All right, so now we have a problem. Let's see who is listening. 0.78 repeated. What is it? Okay, so I want everybody to put 78 over 99. And then I want someone to tell me why that's still a problem. It's still a problem because we can always do what? Tell us, Corey. Yeah, you can always reduce the fraction, right? And what number can we divide both those numbers by? Remember? That's right, 3. Now, again, the rule for 3 is if you add the digits up. 7 plus 8 is what? 15, so it must be divisible by 3. Because 15 is divisible by 3. Okay? Yes. So you guys, I'm not sure you're understanding me. Why didn't I do it on number 5? I mean, that's just like when we did one, you said 0.1 repeating is what fraction? Why didn't I put the repeated sign in? You see what I'm saying? And some of you guys, listen, are asking me questions, and I'm just telling you that's just the way it is, right? You just have to understand that. If I did 1 divided by 9, it would be 0.1 repeating. So we know 0.1 repeating is 1/9. It's not 1 repeating over 9, right? Same principle down here. We're trying to learn to follow the patterns. So what was 78 over 99 reduced? Did you get it? What is it? Yes, I'm very proud of you. 26 over 33. It's beautiful. 26 over 33. Anybody have any issues with that? What? I'm not worried about this test right now. What? So we just divided by 3. Good for you. Just dividing by 3. And let's do the mental math when we're dividing by 3, okay? Let me show you that. Ready? We know 99 divided by 3 is 33. That was an easy one. Okay, but now, let me show you how I recommend 78 divided by 3. All right, if I'm dividing by 3 in my head, I just say how many times does 3 go into 7? 2 times. With how many left over? 1. So I put a 1 right there. That helps me see that the next number is 18. How many times does 3 go into 18? You see what I'm saying there? Isn't that really cool? 26. Right? Did I see that? I hate doing the long division. I did everything I could to avoid division. So I can do most of the division in my head now because of this little nice little thing where I put the remainder up in the top left corner. And then I can read that as what? 18. Does that make sense, guys? Works with all the problems. I'll show you how to do later on, but you really have to do longer division. There's a different, easier way. All right, I'll try to show you that. All right, so is everybody with me now? You guys are asking me good questions, so I'm just trying to make sure now that everybody's listening. All right, is everybody okay with this? All right, let's check out now number 7. I want 2.54 written as a fraction. Tell me.
It's 2 and 58 over
50, good. 2 and 54 over 100. I like that.
And then it's 2 and
Wait a minute. 54, right?
Yeah.
So what is 54 divided by 2 by?
27.
Yes, sir. Thank you. So 2 and 27 over 50. Is everybody okay with that? Is everybody okay with that, guys? Tell me. Yes, it does. Nice, isn't it? You figured it out, right? Division now is pretty easy if you can follow that little trick. It's helpful. Very helpful. Everybody good with that? All right, so here we go. Let's look at the next one. Okay, now it's the new material. I have to give you some notes, all right? I have to give you some notes. All right, so we classified numbers into different sets. All right, the first set, what we say is natural numbers. Right? You guys remember natural numbers? Natural numbers start with what number? Can anybody tell me? No, natural. What are the natural numbers? All right, believe it or not, it's just this. 1, 2, 3, ... Those are the natural numbers. Everybody feel good with that? Just the counting numbers, we say. Natural numbers are just the counting numbers. No decimals, no zero, just natural numbers. All right, if somebody says, what are the natural numbers? You're going to tell them it's 1, 2, 3, 4 to infinity. That's what the ... represents. Everybody good with that? All right. Now, natural numbers can be abbreviated with the letter N. All right, so the next one is whole numbers. What do the whole numbers start with? Does anybody remember? Tell me. No. Yes, very good. Whole numbers start with 0. 0, 1, 2, ... So the only difference between a natural number and a whole number is what? 0, right. Did I agree with that? All right. And we're going to abbreviate that with a W. All right. Now, after whole numbers, this is what we did last week. What did we study last week? Integers. That's exactly right. So I want everybody to write down integers. Now, what did integers include? What did they include? Positives and negatives. So here's what we do. Dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. Are you allowed any fractions or decimals? No, these are just what? Counting numbers or whole numbers. All right? So natural number was N, whole numbers was W. So obviously integers is abbreviated with a what? Very good. Abbreviated with a Z. Yeah, I have no idea why, guys. No idea why. I mean, I have a little bit of understanding because in math, listen to me, sounds kind of funny. In math, there are things called imaginary numbers, or that you'll learn when you get to Algebra 2. So they labeled imaginary numbers with a what? I. So integers couldn't be what? Couldn't be I anymore. So they decided to call integers zentigers, I guess. All right? That's what I want to call them. So again, if you want to abbreviate, you will call integers Z. All right? You call it Z. I have no idea, honestly. I'm telling you the truth. If I had an idea, I would tell you. Yes. Yes. Well, 0 is not negative, but it can be negatives or yes, I got you now. That is correct. It can't be -1.5, though. You with me? All right. Now, after integers, we're learning in this unit, we call rational numbers. All right? And rational numbers, I need you to write down the definition. Rational numbers, simply any number that can be written as a fraction is rational. Say it one more time. Any number that can be written as a fraction is considered rational. Now, the easy way for me to remember that is rational ratio. Ratio just means what? Fraction. All right? Any number that can be written as a fraction is considered rational. Any number that can be written as a fraction is considered rational. Right? So is a natural number a rational number?
No.
Yes. Is a whole number?
Yes.
Is an integer?
Yes.
Yes. So all of these are considered rational numbers. All right? Now, obviously, the abbreviation for rational is what? Very good. Q.
Exactly, I told you.
All right, I'm glad you all figured that out. That was logical. I like that. Z for integer, Q for rational. Don't ask me how they're coming up with these abbreviations. I have no idea.
That makes a lot of sense.
If you don't remember, you have to write out the word rational. If you remember, you can just write what? Q. If you remember integers is Z, you can put Z down.
I know why you put Q for ration. Because there's a quill, you put ration on quill, right?
Okay, here we go. So now, numbers that can be written as a fraction are called what? Rational. So then, what's my next set?
Irrational.
Irrational. Wow, very good. And irrational means what? Say it.
Like it's like a fraction.
Yes, say it. So any number that cannot be written as a fraction is considered irrational. I'm going to tell you. That's a very good question. So I want irrational. I-R-R-A-T-I-O-N-A-L. Irrational. Any number that can be written as a fraction. Any number that can be written as a fraction is rational. Any number that cannot be written as a fraction is considered irrational. All right? Now, here's what I got. All right? So, rational and then irrational. All right? So I want you to make sure you have that definition down. Irrationals. Any number that cannot be written as a fraction. All right. Now, believe it or not, irrational is just IR. Irrational.
Actually makes sense.
Yes. Now, again, I want to give you, who can tell me the most famous of all irrational numbers? The most famous? Pi. That's exactly correct. Pi is an irrational number. All right. Now, why do we say it's irrational? Because it's a decimal. 3.1419562, blah, blah. They've calculated out to hundreds of thousands of decimal places, and they've tried to find patterns. And guess what? There is no pattern, and it never ends. That's what kind of the formal definition of an irrational number. An irrational number is what we say is a non-repeating, non-terminating decimal. The fancy way of saying that is it just can't be written as a what? Fraction. So the formal definition of irrational, you would tell somebody it's a non-repeating, non-terminating decimal. Non-repeating just means the numbers aren't in any sequential order, and non-terminating means that it just goes on and on and on and on and on. Yes, never-ending decimal that doesn't repeat. It doesn't repeat. All right, because obviously 0.3 repeated, are you hearing me? 0.3 repeated can be written as a fraction. All right. Now, there's another famous number, Euler's number, we say is the letter E. On your calculator, you will see there's an E on your calculator. That's a famous number also. When you get to calculus, they'll talk to you about the formal definition of that number, which is absolutely fascinating as well. But right now, you're just going to have to take my word for it. Pi was about 3.1419, and then it went on. E is approximately, we say, 2.7189, and then it goes on and on and on. All right? The other thing that are just different irrational numbers that we haven't really talked about, but we will get to at the end of the year, would be square roots of non-perfect squares. All right, so if I take the square root of 3, it'll be about 1.71, and then it just goes on and on and on and on. It repeats over and over and over with no sequence involved. All right, so again, the main thing out of today's lesson is irrational is any number that can't be written as a fraction. All right, and those are the special cases for those. All right, now the last group here is we're talking about real numbers. All right, now real numbers are what? All numbers that you know about right now. Later on, we will talk about what type of numbers. Who's listening? Imaginary. But we don't know about imaginaries right now. All right? We just know that there are real numbers. And here's the symbol for real. Watch, guys. Watch how it is. 1, 1, and then you make this symbol. All right? That's the symbol for reals. Right. That's exactly right. All right? So again, you just write down this, and then you just make the R. Mm-hmm. With a paragraph symbol, right? Yeah. All right? Yes, ma'am. Real numbers are everything. Everything. So an irrational is real. Natural is real. But like I said, eventually you'll learn about imaginary numbers, which are absolutely fascinating. Yes?
Last year we had like a specific 3.14.
Yeah, but that's just an approximation. That's just an approximation. All right, so here we go. Listen now, please, because I want to get to the rest. Yes, ma'am. Well, E was 2.7. So they're kind of close, but still. All right, here we go. So now what I want everybody to do is I want everybody to look at negative 632. Is negative 632 a natural number?
No.
Is it a whole number?
No.
Is it an integer?
Yes.
So put down Z. Is it rational?
Yes.
Yes. You can make it a fraction. Is it irrational?
No.
It can't be both irrational and rational, guys. So then it's next one is what?
Real.
Real. So if you want, every single one of the numbers is going to have a real next to it. Okay? But let's look at 0.56 repeated. It's 0.56 repeated natural. Whole.
No.
Integer.
Yes. Wait, no.
No decimals. All right? Integers are just counting numbers and opposites. Is it rational?
Yes.
Yes. Is it irrational? Is it real?
Yes.
Yes, sir. There we go. All right, now 21. Let's talk about 21. Is it a natural number?
Yes.
Is it whole?
Yes.
Is it an integer?
No. Yes.
It's definitely an integer. Is it rational?
Yes.
Is it irrational?
No.
Is it real?
Yes.
There you go, guys.
I have a question. Is it rational but not irrational?
That's exactly correct. You can either write as a fraction or you can't. You can't do both.
So, but does it have to know that?
Yes, it has to be one of them. Good question. You're either rational or you're irrational. Yes, sir.
So 9 wouldn't be an integer because it's a
9 is an integer. Oh, number. Okay. Yes, you're correct. This is not an integer because there's a decimal. Okay? All right. Everybody happy with that? All right. That's pretty good, guys. All right. That was like the new information that I really kind of want you guys to think about. All right. Sometimes they'll say natural numbers, whole numbers. Now you know what they're talking about. All right. So now let's take a look now at the next page. All right. So let's go ahead and let's just do as many as we can. All right. 1 and 5, 6. Someone else. All right. Someone who hasn't said anything today. Speak up. Tell me. 11 over 6. If you've said something, I want someone else to speak up. Olivia, you said something today? Why not? All right. Now you're up. Tell me about negative 12. All right. You asked me a question if you have it back there. You're quiet, okay? Negative 12 over 1. Yes, ma'am. That's what I did. Negative 12 over 1. Wasn't there a negative out in front? So 12 over 1 is not the same as negative 12. Good. If there's a negative out in front, the answer is negative also. Okay? All right. Number 13. Go. Good job. Negative 87 over 8. What?
Irrational numbers, how do you know that? Oh, wait.
Yeah. You'll see easily. All right. Go. Oh, let's pick the hardest one, Elise. Good job, girl. 49 over 1. Sweated that one out. All right. Good job. 49 over 1. All right. Here we go. Now, this one's kind of annoying because it requires a lot of simplifying. All right. Tell me what the answer is. Tell me what the fraction is.
Well, I got 300.
3 and...
625 over 1,000.
All right. Hold up. 625 over 1,000. Now we got to reduce that. By what? Say it. Yes.
Divided by 5.
Divided by 5.
And then you get 3, 125 over 200.
Good job. And then?
And then you go, it's...
I'm waiting for you patiently. Divide it out.
So it's 25.
Good. Over.
It's,
5 goes into 20. 5 goes into 20. 40. And then finally?
3, 5.
Yep.
Oh, 8. I think we're done.
All right. Thank you. Yeah, you're done after that. That's for sure. All right. Okay, point 55. 55 over 100 reduces to? Thank you. 11 over. Thank you. You are awesome. Eric, I'm not sure you've said anything to me all year long, man.
I don't know.
All right. I don't know, man. I don't think so. All right. Let's hear it. Loud and proud.
-5, and then 36 is
Beautiful. Tell me.
and 16,
Okay.
and then 18 is 17,
You're awesome. And then?
and 9 is 25.
Couldn't have said it better myself. Beautiful work. All right. Ben. Ooh, tell me about number 18, please. You're brilliant. Now what? Tell me. Do you remember how I showed you? Look up here on the board. I want you to practice. How many times does 5 go into 26? With how many left over? Now I put a 1 up here. Now it's easier for me to see 5 goes into 15. Good. 5 goes into 10. With how many zeros? You see why it's 2 zeros, right? You sure you're good? All right. Negative 53 over 200. Anybody have any issues with negative 53 over 200? Nobody? All right. Last. Ooh, negative 1.3. Nope, you already had a chance. Who hasn't said anything to me today? You said something. You're up. Yes, you tell me. I'm on 19. Come on, no, we're not going anywhere yet.
So it's 1.3.
So that would be negative 1 and what? Say it again. 3 over 10. Beautiful. Yes, ma'am.
Mr. Stroud, the 8th graders on the School Classroom class of 2020, we have 2 things they need to do. PC eggs and the books.
Okay, thank you. I'll tell them. All right. You guys, finish up homework. Great job today.
Aiden, that is correct. I promise.